In this tutorial, we'll generate noise-based moon textures using the MoonTex Library. This is a simple, accessible way for you to create realistic moon textures for use in your projects. So before getting started, we have to install the MoonTex Library along with the Pillow and Noise Library. So open your command prompt and enter pip install MoonTex Pillow and Noise and enter. So this will install all three libraries if you don't have them already installed. Before creating any textures, you have to import MoonTex. So at the top here, we'll do from MoonTex import MoonTex. Then you have to initialize the MoonTex class. So we'll do generator is equal to MoonTex initialized. Now, in order to generate and create a PNG of a single moon phase, you will use the export_PNG method. And so all you have to do is pass in an output path and the desired moon phase. So underneath generator here, we'll do generator.export_PNG. And then I want to save this as new moon.png. And then the phase that I want to export out is going to be new moon. Alright, so if you run the code and look in your current working directory, you should see your image here. I'm just going to open it up real quick. And as you can see, we have our new moon image. So by default, MoonTex includes all 8 of the standard moon phases. And so I'll just list them out for you real quick. You have new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and then finally waning crescent. Now, if you wanted to export all of the moon phases, you could do something like this and individually use export_PNG for each phase. But a simpler way would be to just use the export_cycle method. And so we'll just use that real quick here. So we'll do generator.export_cycle. If I could spell it, cycle. And now all you have to do is pass in where you want the images to be stored at after generation. So I'm just going to put it in the current working directory and just put a dot in there. So now if we run the code and look in the current working directory, you should see that all of the moon phases were generated automatically. So MoonTex has a lot of parameters that you can tweak if you don't like the way the default textures look. So the default size of the PNGs are 300 by 300, but you can change that by passing in a new image size parameter. Image size can either be a single integer for a square image or a width and a height tuple of positive integers. And set the image size to 500 instead of 300. So here's a 300 by 300 full moon and a 500 by 500 full moon. So you can also use the background color parameter to change the color of the default black background that the moon is drawn onto. Background color must be a red, green, blue tuple where each value is between 0 and 255. And so I'm just going to change the background to red. So here we'll do background_color is equal to 255, 0, 0. So here's an image with a red background and one with a blue background. So simplex noise is used to generate the moon texture. You can zoom the noise in and out by changing the noise scale parameter. It must be a positive float, and smaller values produce larger, smoother surface features. And so I'm going to change the noise scale here. So we'll do noise_scale is equal to 0.5. And so this is what the noise scale looks like at 0.2, and here's the noise scale at 0.5. The octave setting determines the number of noise layers that is applied to the texture. Octaves must be a positive integer, and higher values increase detail at the cost of performance. So I'll just give this an octave of 1. So the octaves is equal to 1. Okay, so this is an image with 1 octave, and this is an image with 10 octaves. Persistence determines how much each octave affects the texture generation. The higher the value, the rougher the texture will be. It must be a float between 0 and 1. So I'll just set the persistence here to 0.1. Okay, so here is the persistence at 0.1 and a persistence of 1. Lacunarity controls how quickly detail increases as you add more octaves. It must be a positive float. So I'll just set the lacunarity here to 1. So lacunarity. Okay, so here's a lacunarity of 1 and a lacunarity of 10. The seed is the main setting that differentiates the generated images from one another. The seed can be set to any integer. So I'll just set this to 5,000. Well, 5,000 like that. Here's an image of a seed of 0 and a seed of 5,000. Intensity controls how strong the crater texture is on the moon. The higher the value, the darker and more noticeable the moon craters are. It must be a float between 0 and 1. So we'll just set the intensity to something low. So the intensity is equal to 0.1. Okay. Here is an intensity of 0.1 and an intensity of 1. Invert crater noise swaps which parts of the noise are treated as craters and which are treated as the flat surface. It can be set to either true or false. So we'll just set it to false. So we'll do invert underscore crater noise is equal to false. So this image does not invert the crater noise, while this image does invert the crater noise. Brightness controls how light or dark the moon can be overall. You'll need to pass in a minimum value and a maximum value. The values have to be between 0 and 255. So let's just set the brightness. So we'll set brightness. And so I'll set the minimum value to 0 and the maximum value to 255. All right, so here's an image where the brightness is between 0 and 255. And here's an image where the brightness is between 128 and 255. So there may be times where you don't want the background that's behind the moon texture. So if that's the case, you can set the transparent underscore background parameter to true. So let's go right here and do transparent underscore background is equal to false. Okay. So here's an image with the background and an image without one. So padding controls how much empty space is left around the moon inside of the image. It must be a non-negative integer. So we'll just set padding equal to 10. So padding is equal to 10. Okay. So here's what a padding of 10 looks like and a padding of 20. Shadow factor controls how dark the shadowed side of the moon is. The higher the number, the lighter it is. It must be a float between 0.0 and 1.0. So we'll just set shadow factor equal to, let's see, shadow underscore factor. We'll just set it equal to 0.1. So here is a shadow factor of 0.1 and a shadow factor of 0.5. All right, so that's pretty much it for this tutorial. If you want access to MoonTex's code, it is available on GitHub. Thank you for watching.